We look at our modern marvels, skyscrapers of steel and glass, bridges of impossible scale, and we tell ourselves this is the pinnacle, the ultimate expression of human ingenuity. We see strength in rigidity, in defiance. But what if that entire philosophy is flawed? What if 1,000 years ago, an ancient civilization had already solved some of the most complex engineering problems we still face today? And they did it not by fighting nature, but by listening to it. They did it without computers, without reinforced concrete, without any of our modern technology. They did it with wood. They did it with stone. They did it with a philosophy so profound, it turned the very forces of nature into allies. Their buildings didn't just stand. They danced with earthquakes. They whispered with the wind. And they have stood for 1,000 years as a silent challenge to our modern arrogance. Today, we are going on a journey to uncover the lost secrets of ancient Chinese engineering. We will count down 20 ingenious building tricks, from the cosmic principles of feng shui to mind-bending joinery that defies logic, that allowed them to create the impossible. This is not just a history lesson. This is a masterclass in a forgotten form of genius. Stick around, because by the end of this, you will never look at a piece of wood the same way again. Let's start with a fundamental truth that these ancient builders understood. A building does not exist in a vacuum. It exists in a landscape. The first and most crucial step was not construction. It was alignment with the cosmos. This is where our first category of secrets begins, with the ancient art of feng shui. This wasn't mere superstition. It was a sophisticated system of environmental engineering and cosmic harmony, a blueprint for placing human life within the natural flow of energy, or qi. To build without considering this was to build a body without a soul, a shell destined to fail energetically, even if it stood physically. Trick number 1, sacred siting and orientation. Before a single foundation was dug, feng shui masters would spend weeks, even months, surveying the land with a luopan compass, a complex instrument mapping astrological and terrestrial energies. The ideal site was not chosen for its convenience, but for its spirit. It needed to be backed by protective black tortoise mountains to the north, to shield it from the harsh cold winds and malevolent influences. It needed to face south, towards the crimson phoenix, to embrace the warm sun, light, and good fortune. And ideally, it would have a winding azure dragon stream or river to the east, symbolizing vitality and prosperity, providing vital water and slowing the flow of qi to nourish the site. This precise orientation, as seen in the flawless north-south axis of Beijing's Forbidden City, was the first and most critical defense against the elements. It was passive solar heating and strategic wind protection, encoded into a spiritual practice centuries before the terms were ever invented. They weren't just building on the land, they were becoming a part of it. This leads us directly to trick number 2, axis, symmetry, and hierarchical layout. Order was not just an aesthetic choice, it was a reflection of the Confucian cosmic order, a tangible diagram of the universe itself. The most important building, the throne room, the main hall, was always placed on the central axis, representing the supreme authority of the emperor, the son of heaven. Every other structure, every gate, every pavilion was arranged in perfect symmetry around it, mirroring the stars revolving around the pole star. This created a powerful, imposing progression of space that reinforced social hierarchy, where every step closer to the central axis was a step closer to ultimate power. But the practical genius is often overlooked. This symmetry created incredible structural stability and balance. The weight and forces were distributed evenly across the complex, creating a cohesive unit that could resist uneven settling and stress. It also created an intuitive, navigable layout for vast imperial complexes, where order was paramount to control and ceremony. You can see this masterfully executed in the plan of the entire Forbidden City, a city within a city designed as a single harmonious organism, a physical manifestation of the mandate of heaven itself. Now, let's zoom in from the grand city scale to the human scale, to the very heart of daily life, the Siheyuan, or courtyard house. This is trick number 3, the contained universe of the courtyard. The typical Chinese courtyard home is not a standalone building, it is a square of structures facing inward, enclosing a private open space, shutting out the chaos of the outside world. This design is a microcosm of the world, the square earth contained within the circle of the heavens. Philosophically, it contained and nurtured the key, the life force of the family within, protecting it from being scattered by the wind. Practically, it was a masterpiece of environmental control. The enclosed space provided family privacy and security, a sanctuary. The open courtyard acted as a natural lung for the house. It allowed for light and air to circulate, regulated temperature through convection currents, collected rainwater for use, and often contained gardens, creating a self-sufficient ecosystem. It was a world within a world, perfectly balanced and harmoniously designed for living, a perfect expression of the Taoist principle of inner harmony and balance. And finally, in this category of cosmic design, we have trick number 4, symbolic ornamentation. Every single decorative element on a traditional Chinese structure had a purpose and a meaning, a story to tell. The number of animal statues on a roof ridge. It denoted the status of the building's owner and was believed to ward off evil spirits. A commoner could have none. Only an imperial building could have 10, led by the immortal. The colors. Imperial yellow tiles were reserved for the emperor alone, a direct claim of celestial mandate. Blue often represented the heavens, green represented wood and growth, and red, the most common color, represented fire, happiness, and good fortune, and was also believed to protect against evil. These were not random artistic choices. They were a language of power, of protection, and of philosophy, baked into the very fabric of the building. It was a constant visual reinforcement of the world order, making the building itself a storybook of cultural values that even the illiterate could understand. The building was a teacher, a protector, and a symbol, all at once. But the most profound test of these structures wasn't the gentle sun or the soft rain. It was the violent, unpredictable fury of the earth itself. China exists on the Pacific Ring of Fire, one of the most seismically active zones on the planet. To build here is to invite catastrophe, unless you change the fundamental rules of the game. And that is exactly what they did. Their philosophy was simple. Do not resist the force, accept it, channel it, and dissipate it. Be like the bamboo, which bends in the typhoon while the mighty oak is uprooted. This leads us to our second category, seismic engineering that borders on magic. And it all starts with trick number 5, the crown jewel of this entire system, the dugong bracket. This is perhaps the single greatest innovation in anti-seismic engineering in history. At its core, a dugong is a complex cluster of wooden brackets, looking almost like a wooden cloud, sitting on top of a column. Its primary job is to transfer the enormous weight of the heavy tiled roof outwards onto the eaves, allowing for those iconic sweeping curves. But its secret function is revealed during an earthquake. The dugong is made up of dozens of individual wooden pieces, fitted together with precise joints, no nails, no glue. When seismic energy hits the structure, these joints flex. They slide against each other. The friction between the wooden components absorbs and dissipates the massive energy of the earthquake, converting a violent, building-shattering shock into a gentle, rhythmic rocking motion. The entire building sways like a tree in the wind. It doesn't fight the quake, it dances with it. The Sakyamuni Pagoda, a 67-meter-tall wooden tower built in 1056 AD, is the ultimate testament to this. It has survived over 40 major earthquakes, including one in 1556 that killed over 800,000 people solely because of the genius of its dugong brackets. It's a system so effective that modern engineers now study it to design base isolators for skyscrapers, proving that the ancient way is often the most advanced way. His incredible flexibility is only possible because of the very fabric of the building, its joints. This is trick number 6, flexible mortise and tenon joinery. The entire skeletal structure of a traditional Chinese building is a puzzle, a three-dimensional masterpiece of woodworking. Protruding tenons on one piece of wood fit perfectly into carved-out mortises on another. This is how every beam, every column, every bracket is connected. There is no rigidity. This creates a framework that is inherently flexible. Think of the human body. Our strength and resilience don't come from being rigid. They come from our flexible skeleton and joints that allow us to absorb impact, to roll with a punch. This building is exactly the same. It is a flexible skeleton designed to move as one unified organism, swaying with the forces applied to it rather than resisting them until it snaps. It is the ultimate expression of the Taoist principle of Wu Wei, or effortless action. By yielding, it ultimately overcomes. Now, let's go down to the very base of this flexible skeleton to trick number 7, the floating column. This idea is so counterintuitive it seems like madness. The massive wooden columns that hold up the entire weight of the structure are not buried deep into the foundation. They are not even firmly attached. They simply rest on stone bases. They are, for all intents and purposes, floating. Why? Because during an earthquake, this allows the entire wooden frame to shift and slide on its stone foundations. The energy of the quake is not transferred directly up into the rigid structure. Instead, the building skates on its base, moving as a whole and then settling back into place once the tremor has passed. The stone bases themselves are often deliberately polished smooth to facilitate this movement. It is a breathtakingly simple and brilliant solution, a perfect example of how these builders thought in terms of movement and energy, not just static weight. They understood that to survive a dynamic force, you must yourself become dynamic. And finally, in our seismic arsenal, we have trick number 8, the sacrificial wall. When you look at a beautiful Chinese temple, you see elegant walls of brick or stone. You assume they are holding the building up. You are wrong. In a traditional timber frame structure, the walls are not load-bearing. They are merely infill panels, screens placed between the structural wooden columns. They bear no weight. This means that in a catastrophic earthquake, when the shaking becomes too violent, these walls are designed to fail. They will crumble and collapse. But in doing so, they absorb energy and, most importantly, they leave the primary, wooden skeleton intact. The vital, flexible, life-saving frame remains standing, protecting anyone inside. They designed parts of the building to be sacrificed so that the whole could survive. It is a concept of astonishing strategic brilliance, a lesson in priorities where human life and the core structure were paramount and everything else was expendable. It's a sobering thought that modern hard construction often lacks this fail-safe, trapping people inside when rigid structures fail catastrophically. Building this flexible wooden skeleton required more than just big ideas. It required a level of craftsmanship and precision that is almost unimaginable. This brings us to our third category, the wooden puzzle. Trick number 9 is the primary framework itself, the Tailiang system. This is the method used for grand halls and palaces. Large beams are laid horizontally across columns. Then, shorter columns are placed on those beams, supporting another set of beams, creating a layered, tiered effect that rises to support the roof. This complex framework allowed them to create vast, column-free interior spaces, something incredibly difficult to do with wood. The Hall of Supreme Harmony in the Forbidden City is a monumental example of this system's power and grandeur, creating an awe-inspiring space designed to humble any visitor before the emperor. It was architecture as psychological power, enabled by breathtaking engineering. Of course, to assemble this framework, you need an entire toolkit of joints. This is trick number 10. Specific joints for specific needs. Ancient Chinese carpenters didn't have one universal joint. They had a vast catalog, a secret language of wood. There was the through-tenon joint for maximum shear strength on major beams. There was the dovetail joint, which is famous for locking tighter under tension, perfect for elements that would be pulled apart. There were mitered joints, hooked joints, and countless others, each with a name and a specific purpose. Each one was a precise, engineered solution to a specific structural force. This was applied mathematics and physics carved directly into wood, a testament to the deep empirical knowledge passed down through generations of master craftsmen. This wasn't guesswork, it was a science. This incredible precision allowed for trick number 11, something that sounds utterly modern: prefabrication and standardization. Centuries before the Industrial Revolution, Chinese builders were working from official government manuals like the Song dynasty's treatise on architectural methods that dictated standard sizes and dimensions for every single component. Every beam, every bracket, every column had a defined, modular size based on a system of units. This meant that teams of craftsmen could be working miles apart in different workshops, manufacturing identical, interchangeable parts. The entire building could be pre-cut, numbered, and prepared off-site, and then assembled on location with astonishing speed and perfect accuracy, like a giant, life-sized IKEA kit that could survive earthquakes. It was a system of efficiency and quality control that would not be out of place in a modern factory, ensuring that even on massive imperial projects, the quality and precision remained impossibly high. And the final touch on this wooden puzzle, trick number 12, corbel bracing. While the structure was designed to flex, it still needed to resist constant lateral pressures, like the relentless winds that could howl through the plains. The solution was simple yet effective, adding diagonal wooden braces between vertical columns and horizontal beams. These corbels provided extra rigidity exactly where it was needed, proving that their design wasn't about being flimsy. It was about controlled, intelligent flexibility. It was about knowing precisely when to be rigid and when to yield, a lesson in balance that applied to the entire structure. A building must also contend with another relentless force: water. In a monsoon climate, managing rain was critical to preserving the vulnerable wooden structures from rot and decay. This leads to our fourth category: water mastery. Trick number 13 is the most visible: the multi-tiered, sweeping eaves. Those beautiful soaring roofs are not just for dramatic effect. Their primary function is to throw rainwater as far away as possible from the foundation of the building. The deeper the eaves, the more protection for the wooden pillars and walls from driving rain and moisture, the primary enemies of a wooden structure. It is a simple, elegant, and highly effective form of weatherproofing. But the upward curve at the corner of the eaves also serves a purpose. It allows more light to enter the building while still throwing water far away, a dual-purpose design of pure genius. Look closer at the roof itself. The roof isn't just slanted, it is subtly curved, dipping slightly in the middle. This ingenious design forces rainwater to flow more efficiently toward the center before channeling off the edges. This prevents water from spreading out and dripping randomly all around the building's perimeter. and it creates a stronger, more concentrated flow that is thrown further from the base. It is a passive, self-regulating drainage system that ensures water is directed away from the structure in the most efficient way possible, all without a single gutter or downpipe. It is physics mastered through form. The tiles themselves are trick number 15, ceramic glazed armor. These tiles were fired with a ceramic glaze, making them completely waterproof and incredibly durable against sun, frost, and moss growth. But even here, there was symbolism and hierarchy. The colors, the imperial yellow of the Forbidden City, the brilliant blue of the Temple of Heaven, were a public declaration of the building's purpose and importance, seamlessly blending ultimate function with deep meaning. The glazing process itself was advanced technology, creating a vitrified surface that would shed water perfectly for centuries. This water management extended beyond the single building to the entire city. Trick number 16, the integrated drainage network. Ancient Chinese cities were marvels of urban planning, built on gently graded land and laced with a sophisticated network of underground drains and surface channels. These systems, often beautifully incorporated into the streets and courtyards and hidden under beautifully carved stone covers, efficiently whisked stormwater away, protecting the foundations of entire cities for centuries. The ancient city of Pingyao stands today precisely because of its brilliant and resilient drainage system, a hidden infrastructure masterpiece that kept the city dry and stable through countless rainy seasons. And we cannot talk about water in China without mentioning trick number 17, the Dujiangyan irrigation system. This is not a building, but a landscape-scale feat of civil engineering that dwarfs most modern projects in its elegance and longevity. Built by Li Bing and his son around 256 BC, it tamed the violent Minjiang River not with a dam, but with brilliance. Engineers created a man-made island to split the river, a precious bottleneck channel to divert clear water for irrigation, and a spillway to discharge floodwaters and silt. It works with the river's natural topography and flow, and it is still in use today, over 2,000 years later, irrigating thousands of square kilometers of farmland. It is the ultimate expression of working with nature, not against it, a philosophy made manifest in water and stone. It turned a disaster-prone region into the land of abundance. Our final category encompasses the sheer material and structural genius that didn't fit elsewhere. Trick number 18, the open spandrel arch. While the Romans perfected the solid arch, Chinese engineers pioneered a lighter, more advanced version. The Zhaozhou Bridge, completed in 605 AD, is the world's oldest open spandrel stone segmental arch bridge. This means the bridge has arches within its structure, drastically reducing its weight and, most importantly, allowing floodwaters to pass through it instead of smashing against it. This is why it has stood for over 1,400 years, while countless newer bridges have been washed away. It is a lesson in using voids to create strength, in designing for the event, not just the average. For fortifications, they used what was available: earth. Trick number 19, rammed earth fortifications. Using wooden formwork, teams of workers would rhythmically tamp down layers of earth, gravel, and lime to create walls of incredible strength and durability. These walls had immense thermal mass, keeping interiors cool in summer and warm in winter. Sections of the Great Wall and the walls of ancient cities like Xi'an were built with this technique, proving that humble materials, when used intelligently and on a massive scale, can create structures that last millennia. It was sustainable, local, and incredibly resilient construction. And finally, trick number 20, the organic composite, sticky rice mortar. In a stunning innovation of material science, builders discovered that by mixing sticky rice soup with standard lime mortar, they created a super mortar, The amylopectin in the rice acted as a natural composite binder, creating a mortar that was stronger, more waterproof, and more durable than any other in the world at the time. This slightly flexible organic-inorganic mortar was another tiny shock absorber in their structures, and it is a key reason why so many ancient brick and stone structures are still standing today. Modern scientists who have analyzed it confirm its superior properties. They had literally invented nanocomposite technology over 1,500 years ago by using their most common food staple. It is perhaps the most deliciously clever trick on this entire list, 20 tricks. From the grand cosmic scale of feng shui to the molecular level of sticky rice. But they all point to a single unifying philosophy that our modern world is desperately trying to relearn: the philosophy of harmony. The ancient Chinese understood that resilience isn't about brute force. It isn't about dominating nature with stronger materials and bigger machines. True resilience, the kind that lasts 1,000 years, comes from observation. It comes from humility. It comes from designing systems that move in sync with the natural world, that accept its forces and channel them, that yield in order to ultimately prevail. Their buildings are not just shelters, they are lessons. Lessons in balance, in flexibility, and in respect. They stand as a timeless challenge to our modern arrogance, a silent testament to a different path. They didn't defy the laws of physics. They simply understood them on a level we are only now beginning to comprehend. They listened to the whispers of the wind and the tremors of the earth, and they answered not with a roar, but with a graceful, enduring dance. And that is the most incredible trick of all.